Okay, so we're going to look at one of the new types of factorizing that we have with leaving cert, which is the difference or and sum of two cubes. So we're used to difference of two squares, which is where we have one squared term subtracted from another square term, so with a minus in between them, which gives it that name of the difference. So now we're going to be looking at a kind of similar idea, except we have cubed terms, and between them we might have a minus or a plus because we're doing difference and sum of two cubes. So they're expressions of the form a cubed minus b cubed and a cubed plus b cubed. So the same idea as difference of two squares. We have something cubed and something cubed, and we have two different kind of expressions for each of these. So if we have the difference of two cubes, then that is going to be a minus in between here, and the first sign will be a minus. Okay, then every sign after that is going to be a plus. You can see as well that the kind of factored forms, it starts with just a minus b, a squared plus ab plus b squared. The key thing I'd remember is if we look in between there, it's similar to our perfect squared format, but we don't have a 2 in between it. And the quick way, I suppose, well, I say quick, but one of the ways you can just check if you've got that formula right is to multiply out the bracket again to see do you end up with the original equation, just a cubed minus b cubed, because if you have that 2 there, it can cause some issues in how it factorizes it. So looking at difference of two cubes, I suppose the way that I would remember the signs is that one of these first two signs, so one of these first two signs is going to be negative, and the first sign will always match the type of question you're looking at. So for difference of two cubes, the first sign is a negative. For sum of two cubes, the first sign is a positive, and then the next sign is negative. So one of the first two signs has to be negative, and the first sign will always match with the question. As I've kind of said there, the first sign matches the question, the second sign is the opposite. The last sign will always be a plus. So first sign matches the question, second sign is opposite, last one always match, or last one is always a plus. You need to learn these. You need to learn these off. So these are not in log tables or anything like that that you would be able to use. You just need to know them straight off. So if we're looking at a sum of difference of two cubes, the first thing we would do is factorize using highest common factor if possible, if we can, okay? Because in some cases, or in some of the questions we might have to factorize first and then factorize as a difference of two cubes or sum of two cubes. It mightn't immediately look like one, but when we factorize something out, then it becomes clearer to us. Once we've done that, we're rewriting each term as something cubed, and then we're going to sub into the appropriate formula, so whether it's difference or sum of two cubes. So let's just see how that works. We're going to look at this example and we'll look at a few of the practice questions. Really with these ones, it's just about getting to grips with those formulas, so learning those off and then being able to apply that to the questions for your kind of your A and your B, and taking that idea as well as it's the whole term cubed, so not just looking at the variable, looking at the numbers also. So we'll go through this example and then if you want you can pause and do the practice questions yourself and then come back and check afterwards just to make sure you're on the right lines, I suppose. But let's just look at this first one. So 64c cubed minus 125d cubed. So the first thing we want to do, I suppose, is note that it's going to be a difference of two cubes. So it's going to be a difference of two cubes. And we can see that kind of straight away from the fact that we have that minus in between our two terms there. So we're going to have a difference of two cubes. We maybe write out our formula. So that is that a cubed minus b cubed is a minus b, a squared plus ab plus b squared. So that's our general formula for a difference of two cubes. So our first step is going to be to rewrite each of these terms, so the 64c cubed and the 125d cubed, as just something cubed. So we should be getting used to, I suppose, our cubed numbers, but if we're not sure, we could use our cubed root on our calculator. But in this case, 64 is the same as 4 cubed. So that's going to be 4c all cubed. And then 125 is the same as 5 cubed. So that is 5d all cubed. So once we've this written out now, it's just a matter of us taking each of these and subbing them into the corresponding places in our formula. So kind of noting that in our formula, our A part would be 4c, our B part is that 5d. Those are kind of the places that we're looking at. So A is just the first term, B is the second term. So we're subbing these values in now. That's going to give me 4c minus 5d Then in the second bracket, it starts with 4c, and that's all going to be squared, making sure that we use brackets there, that we don't accidentally write down just 4c squared, because it could be easy then to forget to square the rest of it. You want to keep things clear for yourself from one line to the next, because in an exam situation, it's very easy to kind of forget to go back and do steps. You might think, oh yeah, I know what I mean by that, but when you come to the next line, you may have forgotten. So we just make it as clear for ourselves and as clear for an examiner as we possibly can. And 5d. And you'll notice as well, similar to, I suppose, our difference of two squares, we're not taking that minus with us with the 5d. This time it's 4c cubed minus 5d cubed, and we just take a being 4c, b being 5d. So next we're just going to kind of multiply these brackets out a little bit more, or multiply, I suppose, those squareds and things out a little bit. So that's going to give me 16, sorry, I should have another bracket there. So 16c squared. The middle term here will give me 20cd, and the last term then gives me 25d squared. Okay, and that's my end result. I can't go any further. If I was to multiply it out again, I would just end up back where I started. So we have factorized that into our difference of two cubes there. So looking then at some of these practice questions. So the first one here is going to be obviously a sum of two cubes. So again, we'll start off by rewriting each term as something cubed. So that's going to be 2x cubed minus 5 or plus 5 cubed. Then subbing into our formula as before, it's 2x plus 5. The first sign matches up with the question. The second sign is the opposite. And the last sign is always a plus. And it's b squared at the end there. And then again, we just multiply those terms out for ourselves there. So we get 4x squared minus 10x plus 25 as our end result there. Okay, looking at part 2 here, we can kind of see straight away there with part 2 that we can rewrite that as a difference of two cubes. So 64x cubed, we've already kind of seen that, that's 4x all cubed. 120 or 216 is actually 6 cubed. So we get 2y all cubed. So again, subbing in, the first sign is going to match up with the question, the second sign is going to be the opposite, and then the last sign is always a plus. Okay. And again, it's just making sure we're subbing all those things in properly, okay, keeping for ourselves that this is A, this is B, and that we sub in appropriately, using our brackets there to show that we're squaring the whole term in question. So we get 4x minus 6y, we get 16x squared plus 24xy plus 36y squared. Okay, looking at the next example now, we might know or not know, I suppose, whether 54 is a cubed number, but we can kind of check for ourselves, and this applies to all of the numbers we're doing. If we want to check, we could use our cubed root here, which is the one with the little 3 instead of no number. Okay, we should already know as well, I suppose, that if we have a normal square root, that's like having a 2 there. So the number there just tells us what type of root we're doing. We can try for 54 and see, is it a cubed number? And we can see that it doesn't work out as a nice whole number. So 54 itself is not a cubed number. We can see as well for, let's see, and try 432. But again, since we already know that it doesn't work with 54, we're kind of presuming that it doesn't work with 432 either. So what we need to first do is to try and take out a common factor and see, is there anything in common? So we're going to be doing a highest common factor. Then because of where this is, we're thinking, well, obviously we're doing practice questions on difference in sum of two cubes. We're presuming that's what it's going to give us. But for the moment, if we were looking at it as a new question that we haven't seen before, we would just start by doing highest common factor. We'd go through our different factorizing methods, and that's the only one that's available to us. So we can take out a factor there of, we'll try maybe 2a. And if I take out a factor of 2a, that's going to give me 27a cubed plus 216, 216b cubed. Okay, we're able to take out the a there as well because it's ab cubed and it's a to the power of 4 here. So now we can see that what we're left with in our brackets here is a difference of two cubes, or a sum of two cubes. So we were correct in saying it's a highest common factor first, but then it will be a sum of two cubes. So we're going to rewrite as before. 27a cubed can be rewritten as 3a all cubed, and 216b cubed can be written as 6b all cubed. So I keep my 2a at the front there. I'm going to write my 3a plus 6b, first sign matching the question, second sign the opposite, last sign is always a plus. Okay, so 2a, 3a plus 6b, 9a squared minus 18ab plus 36b squared. And that's our end result for that one. So good for us to see an example of a question where after doing highest common factor, there is more to be done. So if this was an exam situation, we would get some of the marks for taking the highest common factor out, but it could be that just bare minimum low partial credit. We want to be getting at least a high partial credit, if not our full marks. So we would need to recognize that there is more factorizing to be done. We always factorize as fully as we possibly can. Now looking at the last question, this is kind of a particular interesting case. We have b plus 1 cubed minus b minus 1 cubed. So if we just consider this one for a second, although it looks different and we have brackets involved here, when we boil it down, we have something cubed take away something cubed. B plus 1 is our something in this case, and b minus 1 is our other something in this case. So if we apply the same logic, we're going to just, anywhere we would see a, we will sub in b plus 1. Anywhere we see b, we're going to sub in that b minus 1 here, okay? So going to be a little bit more complicated maybe than some of the other ones, but we're going to just try and keep it as straightforward as we can. So when we're subbing in for a, we'll just use our brackets. Again, the first sign is going to match up with the question. Okay, that's going to help us as well to keep our negatives straight there, to keep our values straight. Then in the next case, it's b plus 1 squared. The next sign is the opposite to the first one, so b plus 1 times b minus 1, and the last one always a plus again, b minus 1 squared. So let's just finish by subbing this out. B squared minus b, or sorry, multiplying this out incorrectly. So we have b plus 1 minus b plus 1. And then inside my brackets here, b squared plus 2b plus 1. We can multiply out this middle bracket here as well and get b squared. It'll give us minus b plus b minus 1. And our last bracket, b squared minus 2b plus 1. So let's simplify things down here. So in this first bracket, I'm just going to get 2. In the second bracket, I have b squared plus b squared plus b squared, which is going to, of course, give me 3b squared. I have my 2b here minus 2b, so they're just gone all together. And I have 1 minus 1 plus 1, so that just gives me plus 1 at the end. I'm multiplying out by that 2, 6b squared plus 2. So I think in this case we could leave it in either. We could leave the 2 on the outside, but the general, I suppose, convention, or generally what we tend to do, is if it's a number, we would multiply out that real number. If that was an actual term, we maybe wouldn't multiply that out, or we consider kind of that to be a little bit more factorized than by taking out that highest common factor. But when it's a number, I suppose we would really just multiply across by that. But really either of these probably would have given you your full marks. But a slightly more complicated question, we would get the same answer if we took those two brackets and multiplied them out, expanded them just by the fact that they were cubed, but it would be a little maybe more time consuming to do so. So it's just about whichever you see first. But again, good for us to see an example where it's a difference of 2 cubes, but both of those terms are expressions in their own right. And we could have cases where it might be something like maybe 27x cubed minus a plus 1 cubed. And again, the same thing would apply. We have one thing cubed, take away another thing cubed. But it's just good for us to see these different cases for that. But yeah, basically breaks down to you need to know off those formulas. You have to know off the formulas, and the first step is always, I would say, rewrite as something cubed. Definitely doing that and then using your brackets and making use of those kind of tricks for yourself to keep your question as straight for you as possible. And that's going to help you then just to get them out fully, and making sure that we factorize out as far as possible, as with any of our factorizing questions.